Hello and welcome to the third and final lecture on the lecture series Statistics for Dummies with respect to normal distribution. And today we're going to be solving sums for normal distribution. Now there are a few prerequisites for this lecture. The prerequisites are that you need some problems to solve, of course, and then you need a table, a Z table that is easily available on Google. You need the positive values as well as the negative values for that, and I'll tell you how to look at the Z table. Plus, you also need a calculator just for you to calculate anything that you might require. So let's move on to solving the first sum. If you recollect, we talked about a formula which is Z is equal to X minus mu upon sigma in the last video, right? So what essentially you need is a X value, a mu value, and a sigma value. You need all of these to get a z-score, and if you recollect, a z-score converts an x distribution into a z distribution with mean 0 and sigma 1, right? So whatever values of mean and sigma we get in the x distribution, which might be a skewed distribution or a kurtosis distribution, whatever is the scenario, it will convert it into a normal distribution, right? With a mean 0 and a standard deviation of 1. Yep. So we now want to look at the sum that is offered to us. So the mu value given to us is 30 in the sum. The standard deviation given to us is 4 in the sum. I'll recommend that you read the sum first and then look at the solution. So the mu value given is 30 and the standard deviation value given is 4. Now we need the x value, right? The x value in the first part is given 40, right? So the probability that they're asking for is probability of x less than 40. Now this sign matters a lot. Whatever is the sign, that matters a lot because that is how you're going to look at the z table. And in the z table, you'll find probabilities associated on the left side of the z-score, right? Even on the negative side, you'll find the same scenario. So to look at the table, you actually need the z value, which you'll calculate based on the mu and sigma values that are given to you. So let's do that for the first part, right? So z is equal to x minus mu upon sigma is the first step. And the second step is c is equal to 40, since we're talking about a probability of less than 40. 40 minus mu is 30 upon 4, which brings us to 10 upon 4, which is 2.5. Now we'll represent this as 2.50 because we want values up to the second decimal point, right? So if we use this value, we can now go to the table to find the probability corresponding to the z-score of 2.5. So if you see here, 2.5 and 0, since we are rounding it off till the second decimal point, 2.50 has a probability of 0.9938. It is giving us a probability of 0.09, I'm sorry, 9938. Now if you remember, probabilities can only be between a value of 0 and 1, and for a z-score of 2.5, the probability associated, which is the probability shown on the left, associated is a value of 0.9938. That means 2.5 has to be on the right side of the curve, right? Because the values of probability can lie between 0 to 1, and if the value of probability is very high, that is, it is covering most of the curve, then the value of z of 2.5 should be on the extreme right of it. Right? Now let's move on to the second part. The B part is asking for a probability of x greater than 21, x greater than 21. And if you see the sign, the earlier sign was less than 40, now it is more than 21. Now we calculate the z-score for that, and the z-score can be calculated in such a fashion. So z will be 21 minus 30 upon 4, which brings us to minus 9 divided by 4. And if we go to the calculator, we'll find that that value comes as minus 2.25, which is minus 2.25. And now we can use this z-score to go to the z table and find out the probability for such a score. Now the probability associated with minus 2.25 is minus 2.2 on the left, since this is up to the first decimal point, and in order to get the second decimal point it has to coincide with minus 2.25. The value associated is 0.0122, right? So the probability that we receive is 0.0122. Now remember, we wanted the probability of more than 21, but the z-table always shows us the probability of something happening towards the left or less than 21. If probability of 0.0122 is for the probability of less than 21, we need to convert this scenario to a positive, to a more than 21 scenario. And in order to do that, what we'll do is we'll write 1 and subtract the probability of x is less than 21 from it, which is 1 minus 0.122, which comes to, if we go to the calculator, 1 minus 0.0122, 0.9878, 0.9878. So what this comes to is, if I just remove some values from here, what this comes to is, if you draw it in a diagram, if the probability of something happening more than 21, if x is more than 21 and the probability associated is 0.9878, so 21 has to be somewhere around here, right, for it to have a very high probability associated to the right. So again, what we did was, when we look at the table, we get the probability of less than 21, and then in order to convert that to a probability of more than 21, we'll find out the probability of less than 21, which was 0.0122, and we'll subtract that probability from 1, so that we get a probability of 0.9878, right? Which necessarily means that 21 is on the left side of the normal distribution curve. Finally, we're going to look at the third problem. So if you look at the third part, which is C, we get to see that we need the probability of x, which is greater than 30 but lesser than 35. So what we're talking about is, we need to find the difference. So if we just plot it here in the x distribution, right? If 35 is here and 30 is here, so 35 is here and 30 is here, and if we need to find the probability of the difference between these two, we'll have to find the probability of 35 first. Let me highlight that with yellow, which is this whole area. towards the right, towards the left, and then subtract the probability associated with 30. If I then mark that in pink, it will only be to this area. So we are necessarily talking about just the probability in this green demarcated area, right? So first we need to find the probability of x is less than 35. Then we need to find the probability of x is less than 30, and then subtract each other, right? So let's do that calculation. Let's take c is equal to x minus mu upon sigma, and then we put 35 minus mu is 30 and a sigma of 4, which gives us 5 upon 4, which gives us 1.25, which gives us 1.25, right? So let's keep that for now. This is the first part. The second part is c is equal to x minus mu upon sigma, and the value that we need to calculate is 30 minus 30 upon 4, which is 0, is the z-score. So we have these two z-scores, and we'll find out the probabilities associated with that. So the probability, let me now change the color to orange. The probability associated with a z-score of 1.25, which is the probability of x less than 35, is 1.2 on the left and 0.05, which is 0.8944. Right, write that down. We're talking about a probability of 0.8944, and then we need to find out the probability associated with x is less than 30, which is essentially on the z table a value of 0, and 0.0 is always 0.5000, right? So 0.5000, and now we need to find the difference to get this area, right? So 0.8944 minus 0.5000, which gives us 449 and then 3. So 0.3944 is the value of this area. I hope you have understood this problem. Now we can go to the next one. We'll get to some harder problems now. So for a certain type of computers, the length of time between charges of battery is normally distributed, and and the mean associated is, if you look at it, is 50 hours, and the standard deviation is 15 hours, right? John owns one of these computers and wants to know the probability that the length of the time will be between. So then he's asking about the probability of length of time between 50 and 70, right? So what do we need to do? If you plot that in a curve, we'll have to find out 70 and 50. The probability associated with 70 will be this green shaded area, and the probability associated with 50 will be this blue shaded area. We'll subtract both of them to get this red shaded difference, right? So let's find out the z-score related to 70. So 70 minus 50 upon 15, which is 20 upon 15, which is 4 upon 3, which is 1 point, should be around 1.33. This is the z-score. Now if you calculate the z-score for 50, it'll be 0, right? So we're talking about a probability representing 1.33 z-score and a probability representing 0 z-score and the difference between them, right? So let's go to the table and find out these probability values. 1.3 on the left and 0.03 here, so that's 0.9082. And let's go and find out the probability of 0, which is always 0.5000. So the value comes out to be 2804, 0.4082, right? Now let's solve the final sum that is there in our list of sums. So the length of an instrument produced by a machine has a normal distribution with a mean of 12 months. So we'll write that mean is 12 months. And the standard deviation is 2 months. Find the probability that the instrument produced by this machine will last less than 7 months. So we are asking for a probability that x is less than 7 months and a probability that x is between 7 and 12 months, right? So let's find out this probability first. How we can do that is z is equal to x minus mu upon sigma. That is, we're asking for an x value of 7 and we're subtracting a mean of 12 from that and dividing that with 2, which is minus 5 upon 2, which is minus 2 point, we're asking for a value of minus 2.5, right? Yeah. So the z-score is negative 2.5 and the probability associated with that comes out to be, if you go to the negative chart, negative 2.50, right? So the value comes out to be 0.0062. Probability is 0.0062. Now, if you want to look at this probability, we've already found the probability of x is less than 7. We actually need to find out the probability of x is less than 12, which is z is equal to 12 minus 12 upon 2, which is 0, and the probability associated with x is less than 12 is always going to be 0.5000. And if you want to find out the probability that 7 is less than x and x is less than 12, then the probability comes out to be 0.5000 minus 0.0062, right? 8399. So the value that we got is 0.9938, right? So what we are seeing with the first example is that the probability of x value of 7 shows only a small minuscule probability of 0.0062 towards the left, but when we actually find out the probability between 7 and 12, we find that the probability associated with 7 is so less that the probability between 12 and 7 comes out to be a very big number, which is 0.9938. I hope you found this lecture intuitive and easy to understand. I know it was a long lecture, but I hope it solves all the queries. I'm open to take any questions. So have a nice day, guys, and enjoy. If you like the video and subscribe it. Thank you and have a nice learning experience.